Hello students, in previous video we described about geometry and shape of molecules according to Vesper theory. Today in this video we discuss about valence bond theory which describe structure of molecules. And here we should discuss about valence bond theory. Valence bond theory is given by or valence bond theory. This theory were explained by Hitler and London. In this theory, it is explained that the outermost shell or valence atomic orbital of an atom take part in chemical bonding. It is based on given postulates. At first, valence atomic orbitals overlapping causes chemical bond formation takes place. Or in chemical bonding, valence atomic orbital participate. Only those atomic orbitals take part in bonding which has or which are half filled. Atomic orbitals can hold 2 electrons, and if it is half filled, then only participate in bonding. Two atomic orbitals of having opposite spin of electrons only involved in bonding. If atomic orbitals having same spin of electron, or if it revolve around the nucleus in the same direction, then do not take part in bonding. When their direction of revolution is opposite, then only participate in bonding. The extent of overlapping decide strength of chemical bond, or bond formation takes place by Overlapping of atomic orbital depends upon extent of overlapping. Greater the overlapping strength, stronger is the bond. Greater the extent of overlapping, stronger is the bond. And here, according to this theory, atomic orbitals having opposite spin of electrons. Suppose s orbital, two s atomic orbitals having opposite spin of electrons, then only overlapping takes place and chemical bond formation takes place. And when these atomic orbitals are apart from each other, like a more distance, then do not take part in chemical bonding. When these brought closer, and in this causes here atomic orbital overlap, and it causes here sigma bond formation takes place or bonding takes place. Bonding takes place. Strength of a bond can be determined on the basis of extent of overlapping, and how overlapping takes place that help to decide about the type of bond. And now we discuss about formation of sigma and pi bond. In any compound, when there is overlapping between s atomic orbitals or sp atomic orbitals or pp atomic orbitals, then which type of bonds are formed? And here we describe about formation of sigma and pi bond. At first we discuss about sigma bond, denoted by sigma bond. If any here where there is single bond presence, then it is sigma bond. And we write the bond formation or bond formed by overlapping of SS atomic orbitals or sp atomic orbitals or pp head to head atomic orbitals. Is called sigma bond. That is here already clear that sigma bond is formed by SS overlapping, SP overlapping or PP overlapping. And how sigma bond formation takes place, here we discuss about SS overlapping. Suppose two atomic or two s atomic orbitals overlapping of two s atomic orbitals, s atomic orbitals causes sigma bond formed. And here we describe about s atomic orbital having a spherical shape when it has electron of opposite spin. 2s atomic orbital having opposite spin. And when overlapping takes place, then it forms bond, and it is called sigma bond. Sigma bond is formed by SS overlapping. As for example, in case of hydrogen having only one valence electron and atomic orbital is 1s, when it fused with another hydrogen, then it forms hydrogen molecule, and it is called H2, and here bond formation is sigma bond. And in this way, sigma bond is formed by SS overlapping. And now we discuss about how sp orbital causes sigma bond formation takes place. Second type of overlapping for sigma bond is sp overlapping. In sp overlapping, one s atomic orbital, half filled electrons, one s atomic orbital, when it overlap with one p orbital having electron having opposite spin, in this way it forms the atomic or molecular orbital of by sp overlapping. And here the bond formation is sigma bond. And here we define the chemical bond or formed by sp overlapping is sigma bond. And here S is spherical in shape and P may be Px or Py or Pz. It doesn't matter. But when it overlaps that, then Sp overlapping takes place and it causes sigma bond formation takes place. And here example of such type of Sp overlapping is hydrogen. In case of hydrogen, atomic orbital is 1s1, s atomic orbital. When it fused with hydrogen having only one electron, in case of chlorine, here 1s2, 2s2, 2p6, 3s2, 3p5, and here 3p is valence atomic orbitals, and 3p can hold, listen here, 5 electrons are found there. The first we fill singly and then pairing takes place. One p orbital remains empty. The one p take part in bonding, and here we write Cl contains 1 electron, and that causes the bond formation takes place between s and p orbital, and that is sigma bond. And here we write HCl is molecule is formed, or it is called molecular orbital. And which bond is formed there? Sigma bond is formed. And in this way, here we discuss that here, when there is overlapping between S and P atomic orbital, then it forms sigma bond. Other third type of overlapping that causes sigma bond formation takes place is PP overlapping. When two p atomic orbitals overlap with each other, and when there is head-to-head overlapping, like a p atomic orbital, when it overlap with another p orbital, and on that condition the bond form is here sigma bond. It doesn't matter that here which p atomic orbital, but here head to head overlapping is most essential, and it should be like that. And here bonding form is here sigma bond, and here we write the bond formed by head to head overlapping of pp atomic orbitals is sigma bond. Here we should mention that head-to-head overlapping is most essential. When side-by-side overlapping takes place, then it could not form sigma bond. It is another type of bond which is known as pi bond. And here we explain about that here. Suppose two chlorine having, already we discussed in a structure that here chlorine atom contains one empty p orbital, suppose px, or p orbital of chlorine. It combined or overlap with here another atomic orbital of chlorine, that is head-to-head overlapping takes place, and in this way the bond formation takes place between two chlorine atom, causes chlorine molecule is formed, Cl2 molecular orbital, and here in that overlapping, head-to-head overlapping takes place and sigma bond is formed. In these all three conditions we found that sigma bond is formed by axial overlapping, and therefore it can't rotate about axis, and greater extent overlapping takes place. Therefore a stronger bond or stronger in nature, sigma bond is stronger in nature when pp head-to-head overlapping takes place, ss overlapping takes place, or sp overlapping takes place. Then greater extent of overlapping is possible and the bond is stronger in nature. After that we discuss about next type of bond formed by overlapping of orbitals, which is known as pi bond. Or pi bond is always formed by side or lateral overlapping. The bond formed by side overlapping of p atomic orbitals is called pi bond. In pi bond generally p atomic orbitals participate, and here which type of bonding is possible, that is side by side bonding is formed. As for example here, when there is two atomic orbitals and when these atomic orbitals overlap and its or overlapping is like that, or here overlapping takes place and it causes molecular orbital is formed. Here atomic p orbitals, atomic orbital, and here molecular orbital is found. And here we found that side by side overlapping takes place. Here side by side overlapping causes two p orbitals comes in contact with each other, and here pairing of electrons takes place, and that extent causes pi bond is formed. And here the bond form is pi bond. Pi bond is found that here it form cloud of electrons on both sides of axis. See here above and below, both sides of axis found. And here that causes it can rotate about or rotate freely about axis. And while overlapping side by side, less extent of overlapping takes place, and in this way such type of bond is weaker due to less overlapping. And in this way we can differentiate between sigma bond and pi bond also. After that we discuss about how sigma bond and pi bond formation takes place in some molecules. As for example, here we consider some example like in hydrogen molecule, in oxygen molecule, or in hydrogen already we discussed that here 1s atomic orbital overlap with another 1s atomic orbital having electron of opposite spin, and that causes the bond form is here it is called H2 molecular orbital. And here bonding is here the bond form is single bond, and always in here single bond is found than sigma bond, and which explained by overlapping of 1s atomic orbitals. Similarly, we can explain such type of bond formation in oxygen. In oxygen molecule, two oxygen atoms participate, and the valence atomic orbital of both oxygen are p. And here we describe structure of that atomic orbital and how formation takes place, how sigma and pi bonds are formed in oxygen molecule. Oxygen molecule made up of two oxygen atom, and here oxygen contains 1s2, 2s2, 2p6, and here 2p4 is found here. 2p is the atomic orbitals, and in 2p atomic orbital 4 electrons are present. And here we found that only these 2p atomic orbitals participate in chemical bonding, px or here py and pz. And here we found that here in that state we draw oxygen, px, py and pz is found here. Suppose this is py and pz. One atomic orbital py remains, suppose z is completely fulfilled, and one half-filled orbital found in x and y. another O atom having same structure, px, py and pz. Suppose opposite electrons are found here. Py contains electron of opposite spin, pz having fulfilled atomic orbitals. And in this way we found that when these atoms are atomic orbital of oxygen, when these two atoms brought in contact with each other, then listen here, atomic orbital of two oxygen atom bonded like px get overlap and it form sigma bond. After that here py pz by same way py pz and py having opposite spin of electron and that electron overlap and it form pi bond. And in this way we found that in oxygen double bond is present. One is sigma bond, another is pi bond. And pp overlapping, side by side overlapping causes in oxygen molecule pi bond and sigma bond exist. By same way we can explain the formation of pi bond in nitrogen. In a nitrogen molecule there exists triple covalent bond between two nitrogen atoms. Third structure that we explain on the basis of valence bond theory is nitrogen. In a nitrogen, two nitrogen atoms form combine and nitrogen 1s2, 2s2, 2p3. Here these three atomic orbitals are half filled, or px, py and pz. All the three atomic orbitals take part in bonding, and we can draw a structure like nitrogen atomic orbitals, px having one electron, py having one electron, pz having one electron. Suppose here we write. And another nitrogen having same structure, px having opposite electron, py having same way an opposite spin of electron, pz having opposite spin of electron. And in this way when these atoms are brought in contact, then it causes the atomic orbital form is nitrogen, another nitrogen, and here atomic molecular orbital sigma bond is formed by px, py fused, then pi bond is formed, pz formed, then it causes also pi bond form. And in this way we found that in a nitrogen molecule three bonds exist. One is sigma bond and two are pi bond. And valence bond theory, according to this theory we found that here different type of bond exist, and that bond help to or give of different strength that depends upon extent of overlapping. In the next video we discuss more structure, hybridization and shape of molecules. Thank you.